Hello, my name is Mateusz Hordyński. I'm a senior tech lead at deepsense.ai. And today I have prepared a presentation for you. The title of this talk is Building Racks for Enterprises with Ragbits. So the game plan for today, we will start with introduction to rack systems. Then I will tell you what is Ragbits and why we created it. After that, I will share my selection of finest tips and tricks how to build racks with success. And then, last but not least, we will take a little peek into the future of Ragbits. So, recently, I have finished reading this book. It's AI Engineering by Huan Chip, and I really recommend it. And in one of the first chapters, you can find this graph. And on this, we can see how willing are enterprises to use LLMs for different use cases. The first thing you can see that the most use cases are actually internal facing, so inside the enterprise. And the most common categories for use cases are text summarization and enterprise knowledge management. So I see the same thing in my experience. The most common thing for me to do on the projects are actually enterprise knowledge management, so building racks. And you may ask yourself, like, why do we even need racks? Like, LLMs already know a lot of stuff. And let's look at this example. So we have a question from the user, a very simple one. What is capital of Poland? Of course, the LLM will know the answer. The answer is Warsaw. Even a little bit harder question, tell me about the quantum physics. We got probably a good answer from the LLM. But what will happen if we ask the LLM, what is our company policy on refunding external training? And the honest reaction of the LLM probably will be something like this. The LLM doesn't know anything about our internal policies, about stuff in our company, about my private documents. It is trained on the public data in the internet, so it doesn't have any idea of stuff, of the documents, of the knowledge internal to us. So with RAG, with Retrieval Augmented Generation, we can provide that knowledge into the LLM. So basically, the architecture, like from a very high level, looks like this. We have a question on the left, we have the answer on the right, somewhere in between, we have a system that puts that knowledge from different sources, like documents, databases, graphs, into the prompt, so the LLM can answer. In a nutshell, to create a rack architecture, what you need to do, you start with parsing your documents, with splitting them into the chunks, and embedding them using embedding model. After that, you put them into the vector database. So we have stored our data into the vector database, and then if we have a user asking a question, what we do, we take a question, we again embed the question, so we get the vector. Having the vector, we ask the vector database, okay, find me the most relevant chunks of knowledge for that specific question. We put the context, the retrieved chunks into the prompt, and we generate the answer, having a prompt like generate an answer for this question, knowing that some context. So you may ask yourself, is building racks hard or not? And this is my favorite post from subreddit, from rack subreddit. Trying to build a rack chatbot turned into my worst nightmare. And I really feel the person behind that post, because creating the POCs is really easy. Like, you can create the rack system probably in hours. But the complexity is when you need to scale it up or go to production. So scaling up racks is hard. And that brings me to why we created Ragbits. We wanted to make this part easier, to make it easier to go to production, to make real products. And the history behind ragbits looks a little bit like this. It was probably, we started to think about, okay, we need to create these projects, these types of projects in a repeatable way, like make it fast, make it in good quality. And we started with sharing some code snippets, like how to handle monitoring, how to handle caching, how to handle different things. We just shared these code snippets between us. Then we packaged all these reusable components in some sort of library or framework. And finally, we decided to open source this technology as ragbits. So the ragbits is open sourced. We released the 1.0 version in June 2025. It's composed of different modules. So the idea behind that is that you install only what you need. We have a module like ragbits core for all the essential tools you need in every LLM project, like prompts, LLMs, vector stores, observability. But also we have a dedicated module for RAG, so ragbits document search. We have dedicated modules for chatbots with API and user interface. We have also modules for evaluation or developer tools. Ragbits is designed to help you to develop any application related to the LLM. So not only development of RAGs, but also other LLM projects. But in this talk, we'll focus on the RAG part. So in ragbits, to create a simple RAG, it's very easy. You just need couple lines of the code. Here on the screenshot, we have everything to create a very simple RAG application. So we start with document search instance, and this is the main entry point for any RAG-related feature in the ragbits. It provides you methods for both ingest and search, so you have just one class, one instance, one object to perform both ingestion of the documents and then searching through them. And to create the document search, what you need is a vector store and embedder. In ragbits, we have support to different vector stores like Qgrant, pgvector, Chroma, soon Weaviate, and we have like dozens of different embedder models. And you can fetch the documents for the ingestion from different data sources. So if you have the documents on the web or maybe on any of the major cloud providers or even Git or Hugging Face, you can just connect directly from ragbits to this source, and it will be downloaded in the background. Okay, so how to actually build successful RAGs? And I'm going to cover 4 areas of RAG applications. So it's going to be ingestion, retrieval, observability, and something which I called time to market. And my presentation is going to be agnostic to the technology that you are using. So whatever framework you are using for the RAG, you probably can apply these techniques. But some of the slides will be ragbit specific, and then we will have the rabbit emoji, and that basically means that I'm showing ragbit specific implementation. Okay, so let's start with ingestion. And the first thing you need to do in the ingestion is parsing documents. Usually out there, creating the projects, you will see a lot of PDFs, a lot of Word documents or docs, Google Docs or HTML pages. Probably you won't see too much normal plain text or Markdown. And while these simple formats can be simply chunked, you just split them by some character, other formats needs to be parsed. Like imagine in the PDFs, you have columns, you have tables, you have images, different layouts. You just need some piece of technology to parse it for you, to make it more readable for the machine. And the most popular libraries for that are Unstructured I/O and Docklink. And in ragbits, we have the default parsers. We have it implemented already in the document search instance. So ragbits does this thing for you. What you can do you can configure a specific parser per document type. So here, let's say for the PDF documents, I want to parse them by doclink with doclink, but for the EPUB, I want a custom parser. If you need more detailed routing, like for example, by document size or document source or something else, you can create always your own router and route the documents to different parsers. Out of the box in ragbits, we have doclink and unstructured parsers. But you can create the custom ones, and this is a very straightforward and well-documented process. So if you have very custom documents, you can just always create a custom parser. So I said before that you will see a lot of images, charts, and all the complex data structures, let's say, or elements in documents, and what to do with them. What's really work for me on different projects is actually using the multimodal LLM to describe these images. So it looks like that you use either unstructured or doclink to parse the document, and you will get either text chunks or images. And with these extracted images, you just grab them, you paste them into the prompt of the multimodal LLM with surrounding text, and you get the description that you can later embed into the vector database. So example prompt for that may look like this. So we instruct the model that your task is to provide a detailed description of the image, and the image is a part of bigger PDF document. Later in the user prompt, we have some chunk of the text before the image. We have the image itself, and we have chunk of text after the image. And as you can see, we got an answer from the LLM here. So the image is a step-by-step guide. Here we have different steps from the image, and we get the information that this process should be done monthly. And as you can see, some of this data was only available in the text itself, some of the data only in the image. So this is important to have both together to extract what's really, really important in that specific part of the document. And in ragbits, we have it also implemented. We have a concept of enrichment in ragbits. And it looks like that you can configure how particular types of elements are extracted from documents will be enriched. And what I mean by elements, it's just the elements of the documents. And the most common elements are either text element or image element. And out of the box, you have image descriptions with multimodal LLM, so exactly what I shown you. But for example, you can have different enrichers. Like let's say for the text elements, you want to have summarize enricher, and you can summarize every text element, and it will be done during ingestion. Jumping to another thing about the racks, data volume is important. And I actually seen this multiple times, that we have tools available to us, like in this particular case, we have a custom GPTs from OpenAI, where it's really easy to create your rack application. You just create a custom GPT, and here I have highlighted the part of the website where you can just upload the files, and it will create the rack for you, like parse the documents and create the agent or chatbot to talk with these documents. And I've seen this multiple times, actually. I had this conversation with somebody who told me, hey, I created this custom GPT like in 2 hours. And right now, let's do the same thing, but I will have like 20 terabytes of documents. And it should be easy, right? So I think the perception is a little bit, you need to remember that with the scale and with the data volume, you will encounter some problems. And the first thing with massive data sets are that even ingesting this data will take a lot of time. And probably you need to repeat that process multiple times when you want to like tweak the settings and test things. So with ragbits, we have a Ray implementation, integration. And Ray is basically a tool that allows you to run tasks on the cluster in distributed manner. Imagine like you have a loop with 100 iteration. Every iteration can be on different machine, basically. And with ragbits, you have just one line that enables distributed document processing on Ray clusters. If you add it to the document search instance, it will connect to the cluster and submit the job there. We have also a cookbook by Paweł Chmielak on our website. In this cookbook, in detail, we have instruction how to set up rag ingestion with ragbits, Ray, and Quadrant. Okay, so going into the retrieval strategy, I will start with history handling. And with history handling, we have this thing like, why do we even need that? So I prepared the example for that. So let's say that user is asking a question, what is our company policy for refunding external training? And the query to the vector database will be basically the same thing that the user asked. And we got the policy as a response. We got the response of the AI. You can get a refund if you have your manager approvals. But here we have a follow-up question from the user. Is there any limit? And if we don't handle history correctly and we will just send another message to the vector database, probably the vector database will be like, what? It doesn't make any sense. This question, this follow-up question doesn't make any sense to the vector database, and we'll get just not correct, not relevant information for the thing that the user is talking about. So what you can do, you can handle the history with an LLM. Here I have, again, very simplified prompt. Usually you have a little bit more instructions, but the instruction is that your task is to create a standalone question from a history between user and assistant. Here we have the history from the previous example, and the LLM just generated like a standalone question compressed into one question, like the whole history compressed into one standalone question. And we have this approach also implemented in the ragbits chat module, so the module for creating chatbots. You just import our message compressor. You call the compress method with the history, and you will get the compressed message. The other thing to remember, and maybe technique to improve your quality of your RAG responses, are query rephrasing. So the problem here that we want to solve is that users ask a question in very different way that it is in the documents. Like the question, like the type of writing the question is very different from the writing in the documents. So here we have, of course, like, let's say, example that this is a very, very different text that we will see in the documents. But what we can do with this, we can ask, again, the LLM to rephrase the query, or even to rephrase the query multiple times. So in this instruction, I say that your task is to generate n different versions of the given query. And for the user query, for the user question, in this case, I configured it to return the 3 different rephrased variants. I get the 3 variants, and what I can do, I can query the vector database 3 times, and then compress the results into the one final result. And thanks to that, I will have like triple my chance to get the correct chunks. Like I have the more chances, I have a bigger chances to get what I'm looking for. Another thing, especially with the multi-query rephrasing, is the fact that vector databases are really good with returning the relevant results, but they are not especially good into making them sorted from the most relevant to the least relevant. So the idea here is we can use some sort of different model, like just a specific model to perform this task. These models are called rerankers, and they basically work in that way that they will take the results returned from the vector database and they will sort them from the most relevant to the least relevant result. And both of these approaches are available in the ragbits. So again, what we do here is we just configure, we add extra configuration to the document search instance. And here we have LLM-based query rephraser. I configured it to return the free variants of the query. And here I also configured LLM-based reranker, which is using actually only LLM to re-rank the queries by using the log props. So this property which says to you how the LLM was sure about the answer. And having that numeric value, you can sort the results. And it works really good and doesn't require you to have an additional model. But we have more implementations to choose from. There are multiple re-rankers in ragbits integrated. You can also integrate the customs ones in our documentation. You can browse through all the variants. And last but not least, probably I would say this is the simplest yet most rewarding technique is the hybrid search. So if you don't have time for any other tweaks, you just want a quick results, I would go for the hybrid search. And what is hybrid search? So basically, we have two types of vectors or embedding models. We have the dense vectors and we have sparse vectors. And in very simplified words, what they do. Dense vectors are really good with calculating semantic meaning, and the sparse vectors are really good with exact words. It's very simplified, but in this example, you can see that we have a quiet home, 2-bedroom in Pinewood. You can say quiet home in multiple ways, like peaceful home or something different, and this is still the same. You still want to find the result. But in case of Pinewood, I only care about Pinewood. I don't care about, I don't know, Sprucewood. I just want the exact word. So having these two models together make this type of queries where I care about both semantic meaning, but also for some keywords is really, really good. And after running these both searches, you will get results from both dense vector and from the sparse vector. You need somehow to mix them together. So for that, usually you use some sort of fusion algorithm. And in ragbits, we have implemented hybrid search. We have multiple sparse embedders available. So you have multiple dense embedders, multiple sparse embedders. You can mix and match them to make the good results for your data. You can also mix and match as many vector stores as needed. Actually, our implementation works on client side, so you can have even different vector stores, and they will be called and then mixed together, and the results from them will be merged together by a fusion strategy. So here in this example, we have a distribution-based score fusion, but we have also a different implementation to choose from. Okay, so debugging and observability. I would say tracing, I always repeat that on every project that I do. tracing is your best friend, and especially in the applications that you have like non-deterministic model hallucinating weird things in the core of your application. Yeah, like if the client sends you an email that something doesn't work, you really need to know what happened under the hood. And what I usually do for tracing is just open telemetry. So old technology, let's say like technology which I believe was there before all the LLM stuff, but it works for that as well. And you shouldn't forget about monitoring. So as in any production application, monitoring and alerts are important. If you go for production, you should have some sort of monitoring. You should have some sort of automatic alerts. If something breaks, you should know that before the users. And the most common metrics to track, both in RAG and chatbots, is the time to first token. So how many times user waited from sending the message to the first letter on their screen. Maybe token throughput, output token count is important to limit the bills that we are paying to the OpenAI or different provider, and things like conversation history length or maybe generation cancels. So how many user actually canceled the generation in the middle? Probably that means that something went wrong. And in ragbits, all the components are orchestrated with monitoring and tracing. So you just add 2 lines of code to enable open telemetry across the application. You will get basically for free the traces, and you will get the metrics for free. And in that case, I'm using OpenTelemetry to OpenTelemetry audit handler, but we have also different audit handlers, let's say console printer. So every trace will be printed to your console when you're developing locally. And you can define custom handlers if you have custom audit system, custom system you want to store your logs, you can do that. And the time to market. What I mean by that, when you create these RAG applications, you want to go really fast, like show the first value, show the first POC really fast to the users, because usually you have some sort of domain subject matter experts, domain experts that will be able to validate if the answers are good or not, and you want to iterate fast. So we noticed that creating like even really simple front ends for every project, like even in Gradio or Streamlit, just takes time and effort of the team. So we created the ragbits interface. And it's very, let's say, open-ended. Basically, the interface looks like that. You have a chat interface, a class provided by ragbits, and you have 2 methods in there. You have setup, where you just initialize any database connections, LLMs, and stuff like that. And you have a chat method where you have message history and user context. And you just put your application logic in there. You just yield the response from that method, and you will get the API and user interface basically for free. And even better, if you want to create full ragbits application, we have prepared our template starter. It's called Create Ragbits App. Basically, what you do, you run UVX or PPX, or you just install Create Ragbits App package, and it will start some sort of a form in your terminal where you can select one of our templates. Then it will ask you for the project name, for the vector database you want to use, for parser which you want to use, either docklink or unstructured, and it will allow you to have extra features like hybrid search, image descriptions with the multimodal LLMs, or the observability stack with Grafana, Mateusz, and everything configured. And you will also get Docker files, PyProject, README, just everything. The whole project is generated by this tool. And the last chapter of my talk is what is coming to Ragbits. So right now we are working on agentic workflows. So we released 1.0 version on the 4th of June. And we started to work in 3 different streams. One stream is the agents. Right now, we are in the point that we have a tool use and we have the basic agent interface already implemented in Ragbits. Then we are going to look into MCPs, into agent-to-agent protocol, but also we work on UI improvements where we create a TypeScript lib to create a custom frontends. Also, we will have agent-specific UI components, and we work on different integrations like Weaviate, OPIC for observability, or Open Web UI. And one thing to mention is that our backlog is available on GitHub projects. It's public, so you can just always go there and see what's happening in the team. And of course, you are more than welcome to submit new feature requests on our GitHub. And one last thing, a sneak peek, let's say, into the next release. So here we have an agentic RAG implemented in Ragbits 1.1. And basically how it works, you just pass the document search instance, so the instance you should be familiar with after this talk. You just pass it as a tool to the agent interface, and the agent will decide on its own when to call RAG with what query, and basically you have full agentic system capable of querying your data. So that's it for this talk. Thank you for listening, thank you for coming, and I really encourage you to check out Ragbits on our GitHub. Thank you.